All right, folks, just having a little bit of fun with my computer stuff today. Kind of screwing with your mind seeing a double image here, but I want to get out of here and get right into today's lesson. We're going to be talking about triangle inequalities, so things that are not equal within triangles. So I want to get after that right away, so I'm going to stop playing around and wasting your time, and let's take a look actually at something I want to show you. So I'm going to go to a video that I actually made many years ago, and I want to see if you guys can answer the questions I have from this video. So here's what it says. Can you construct a triangle with the given lengths 4, 5, and 8? So take those three pieces right there. See if you can put that together in your mind and figure out if a triangle can be formed. So as you do that, I am going to go ahead and draw out these segment lengths. So the first one will probably be 4, or maybe it's the 8. Oh, it's the 8, okay? So I'm going to take a segment the length of 8, put that there, and now I'm measuring the length of 4 units with my compass there, and I want to transfer that length down onto my segment down here. So anywhere along this arc is going to be 4 units from the endpoint that we currently have down there. I'm going to do the same thing with the 5-unit long segment, placing it at the other endpoint. And any point along this arc is going to be 5 units from that other endpoint. Now, the important thing is where those two arcs intersect, that's where the triangle would be formed. So is it possible to form a triangle with side lengths 4, 5, and 8? The answer is yes. Okay, that length can be formed, that triangle can be formed. Okay. Now, what I want you to be thinking about as we transition to these other examples is what makes this triangle special? What makes this these lengths able to be formed into a triangle versus the other ones that we're going to take a look at here in a second and see if they form into a triangle as well. So as we look at this next example, in this example we are given lengths 4, 7, 11. So again, I want you to take that, kind of try to put that together in your mind. Does that form a triangle? I'm going to continue to let this run. That segment length is 11 units long. Okay. And like the last one, this will be 4 units from that endpoint. And we'll do the same thing with the other side. That one's 7 units from that endpoint. Now, here's the deal. On the previous problem, it was where the two arcs intersected. Well, what just happened there? Well, they intersected, but where did they intersect? On the line, okay? Kind of like a drawbridge. It didn't form a triangle because the intersection took place on the line. So right now, I want you to be thinking, why did the first pair of segments make a triangle and these not? Okay, that's the real key that we're getting at as we move on. Now, the next one would be 6, 4, and 15. Do they form a triangle? I'm really hoping that you can see this one better than the others. And if we look here, unlike the last one that had a drawbridge scenario where it would come down right on top of that line, this one, the bridge isn't even complete, if you know what I'm saying. So as we look here, as we swing that around, you can tell it didn't even come close to completing the triangle, okay? So hopefully you at least had that one there. Now, as we take a look at this last slide, the last slide says, okay, with the first length of 4, 5, and 8, that one made a triangle. 4, 7, 11 did not, neither did 4, 6, and 15. So what was about these lengths that did, but these two that didn't? And here's the answer. Okay, it's there in 512. The sum of these two smaller sides must be greater than the third side. In fact, as you look at this last example here, This is a condensed version of what I want to have you write down, but if you understand this the best, you can write this one down. It means the same thing. In order to form a triangle, the sum of the two smaller sides must be greater than the longest. Okay? Must be greater. So as I look at this, only the first one was true, which is why the first one formed a triangle and the other ones did not. Now, I want to take a look at, let's see here. Let's take a look at the worksheet now. If I can get this working here. All right. And I'd like you to go ahead and fill in the triangle inequality theorem. If I can get that to see any clearer. Try it one more time maybe. There we go, that looks much better. Okay, so the triangle inequality theorem says this, and you want to write this down. The sum of the lengths of any two sides of a triangle must be greater than the length of the third side. Okay, and you'll see how it's laid out right there. The theorem 512 that I just showed you previously, that one is a condensed version of what this is saying right here. It means the same thing. I don't care which one you remember because they both mean the same thing. Okay, so go ahead and write that down. I'm going to go on to example number 1 here. Okay, now in number 1 it says, can the following triangles exist? Okay, meaning that these lengths might not form a triangle. So if I take what it said in the triangle inequality theorem, and the sum of two sides must be greater than the third. The sum of two sides must be greater than the third. And the sum of two sides must be greater than the third. Okay, oops, that should be 9. Okay, so as we take a look at this, does this one work? 9 plus 12 is 21. That is not greater than the third side. Okay, so right now I could say that this is not going to form a triangle. Does not form a triangle. Okay, but I could go through the next one. We have 32, which is bigger than 12, and 35, which is bigger than 9. So in the last two cases it worked, but in the first one it did not. So it does not form a triangle. It has to be true in all possibilities. If I take a look at the next one, 16 plus 18, and maybe 16 plus 34, and 34 plus 18. Okay, 16 plus 18, that is 34. Ooh, it's not bigger than. So as a result, this one would be 50, bigger than 18. 52, bigger than 16. Unfortunately, we didn't meet the requirement in the first one, so this does not form a triangle. Okay, so hopefully you're getting that down there. The sum of two sides have to always be greater than the third side in a triangle. Okay. Now, the next one example says, which side lengths could be the third side? Yeah, two sides of a triangle are 9 and 11. Okay, so here's the deal. The two side lengths, being 9 and 11, have to be bigger than the third side. Well, the two side lengths could be these two, have to be bigger than the third side. And the two side lengths have to be bigger than the third side. Okay, so did you see that? I made the third side x. I'm going to go ahead and solve these. Now, here's what's happening. This is 20. And if I write this from left to right, x being on the left, I'm going to switch this. X has to be less than 20. That's what that's saying right there. Okay, remember, less than. I hope we can read those inequalities. Some of you may struggle. If I subtract 9, x has to be greater than 2. And over here, if I subtract 11, x has to be greater than negative 2. Oh, no way. Has to be bigger than a negative value. Okay, this one I don't even need. All right. So as I look at this, let's see here. I know that x is going to be bigger than 2 and less than 20. Okay. One way to think about this is this. Your unknown side length could be the longest. That's what it would be here. Or it could be one of your two shorter side lengths. That's what's going to be here. Okay. And so it's going to be one of those two requirements. So you don't even have to do this one if you don't want to. So I'm going to mark all numbers that are between 2 and 20. This one's not between 2. This one is. This one is. And this one is not. Okay? So that is the range of possibilities for that third side length between 2 and 20. So 7 and 15, those would make a possible triangle with side lengths 9 and 11. Okay? All right, now, the last example says this. What's the range of possible lengths for a triangle with the given measurements? 19 and 32. Well, again, like we did on the previous example, the third side length might be the longest, so I'll make it like this. But the third side length could be one of the two smaller side lengths, so I'll make it like this. If I solve for x in both situations, 51 and subtracting 19 would be 13. So x has to be less than 51 and has to be greater than 13. That's the range of possible third side length. So could the third side length be 25? Yeah. Could the third side length be 10? No. It's outside that range right there. Could the third side length be 62? No. Again, it's outside that range. Okay? So if I do the last one, again, the third side length could be one of the two longer, or one of the longest side, or the third side length could be one of the two smaller sides. Okay? So if we work this out, x has to be less than 19, and x has to be greater than 5. Okay, so hopefully we have that down there. Again, the sum of any two side lengths has to be bigger than the third side length. All right, so I think that's a good enough justification as to what you need to know before you move on. So take your best shot at the problems I have on Schoology, and we'll take a look at those tomorrow. Thanks for your time. Good night.